Beneath Taylor Glacier, blood falls spills red from Taylor Glacier into the frozen dry valleys of East Antarctica. Flowing within cold brine, the red color is not blood, but iron-rich brine reacting with oxygen after exposure. Flowing beneath sealed ice, explorers once suspected red algae, but later research connected the stain to oxidized iron. Flowing through iron chemistry, a hidden salty reservoir feeds the strange outflow through channels inside cold glacier ice. Flowing under polar pressure, the brine can remain liquid below freezing because dissolved salt lowers its freezing point. Deep beneath Taylor Glacier is cold, yet pockets of hypersaline water can move through internal pathways. Carefully during Antarctic fieldwork, radar surveys help trace brine movement through the glacier toward the red surface outlet. Across Antarctic silence, the source may be ancient seawater trapped when changing ice isolated an old marine basin. Flowing across mineral deposits, as clean ice forms, salt concentrates in remaining liquid and produces increasingly dense brine. Flowing inside Taylor Glacier's fractures, that brine carries dissolved iron released through long chemical interactions beneath the glacier. Flowing before surface oxidation, when the liquid reaches air, iron oxidizes and stains ice with rusty red minerals. Deep inside Antarctic ice, the waterfall appears bloody because red deposits spread across white ice and blue shadows. Flowing inside brine channels, the outflow is sporadic, appearing when pressure and pathways allow brine to escape outward. Through frozen fractures, this system reveals Antarctica is not simply frozen solid, even in extreme cold deserts. Deep inside the Antarctic glacier, the McMurdo Dry Valleys are among Earth's coldest and driest desert landscapes today.
Flowing beneath the frozen Antarctic glacier.
Deep within polar darkness, bloodfalls give scientists rare access to liquid water emerging from below Antarctic ice. Deep through fractures under polar pressure, samples show unusual chemistry, including salt, iron, sulfate, and very little oxygen.
Living without sunlight beneath Taylor Glacier, microbes survive there without sunlight by using chemical energy instead of photosynthesis.
Living inside oxygen-poor subglacial brine, this dark ecosystem demonstrates that life can persist beneath ice in isolated environments. Deep beneath the frozen valley, the system resembles possible habitats under icy worlds, though planetary conditions differ greatly. Living inside isolated chemical ecosystems, astrobiologists study bloodfalls because it tests life under cold, dark, salty isolation. Deep through Taylor Glacier's fractures, the red flow therefore becomes evidence for hidden habitability rather than supernatural horror. Flowing under immense polar pressure, the surface stain exaggerates drama, but the real mystery lives inside invisible chemistry. Flowing across hidden subglacial pathways, iron oxidation is familiar rust chemistry, transformed here into a giant Antarctic spectacle. Flowing before reaching surface oxygen, the brine's salinity makes it heavier and chemically distinct from ordinary meltwater nearby. Flowing through iron-rich mineral water, fresh glacier ice and salty brine behave differently, creating contrasting textures and pathways. Deep across crimson ice, pressure within glacier fractures can push dense liquid toward tiny outlets at the terminus. Inside oxygen-poor subglacial brine, scientists must avoid contaminating samples because microbial signals are delicate and easily disturbed. Deep within the polar ice, clean sampling tools collect brine while preserving chemical gradients and biological evidence carefully. Living beneath frozen ice in darkness, laboratory analysis separates iron minerals, dissolved salts, microbial DNA, and metabolic signatures. Deep under immense glacier pressure, no single measurement explains everything, so researchers combine radar, chemistry. Deep under glacier pressure, the system is dynamic, with hidden water moving slowly through an apparently frozen body. Deep across the crimson outlet, Bloodfalls challenges the simple idea that glaciers are motionless blocks of ice. Flowing inside oxygen-poor subglacial brine channels, glaciers deform, fracture, trap brine, release fluids. Deep below the surface daylight, the outflow path may migrate as ice stress opens and closes internal channels. Below surface daylight, red deposits can accumulate over time, making small leaks appear visually enormous from afar. Flowing inside concentrated salt pockets, oxidized minerals stay behind after liquid drains, intensifying the stain against pale ice. Flowing near dissolved iron, wind, sublimation, and freezing shape the surface patterns after brine reaches the glacier face.
Deep inside sealed channels, the dramatic red color does not mean the water is hot, volcanic, or burning.
Flowing beneath oxygen-poor water, it is a cold chemical stain powered by salt, iron, oxygen, and glacier pressure. Flowing beneath dark glacier layers, the scene looks apocalyptic, yet the process is slow, natural, and chemically traceable. Deep beneath dry valleys, Blood Falls is not a permanent river, but an intermittent seep with changing intensity. Flowing within hypersaline pockets, the red water can freeze, spread, or crust, depending on weather and surface conditions. Trapped inside Taylor Glacier's fractures, salt crystals and iron minerals create layered deposits that record repeated outflow events. Deep beneath McMurdo dry valleys, some iron particles form tiny mineral structures that researchers can analyze under microscopes. Living within oxygen-poor water under pressure, microscopes reveal details invisible to tourists, including grains, biofilms, and mineral coatings. Feeding inside isolated chemical ecosystems, because oxygen is scarce below, microbial metabolism follows pathways unlike sunlit surface ecosystems. Surviving inside oxygen-poor subglacial brine, microbes there may recycle iron and sulfur compounds while using trapped organic matter. Surviving inside isolated chemical ecosystems, the ecosystem is small but scientifically huge because it expands known survival strategies. Trapped beneath sealed Antarctic ice, every red streak connects surface spectacle to a hidden world of chemical energy. Flowing before oxygen reaches dissolved iron, scientists compare brine chemistry with seawater to reconstruct the reservoir's ancient origin. Trapped within oxygen-poor brine channels, marine signatures suggest the reservoir descended from salty water trapped beneath advancing ice. Deep within Taylor Glacier's shadows, over long times, isolation transformed that water into a concentrated subglacial chemical laboratory. Trapped across hidden subglacial pathways, the glacier acts like a lid, preserving darkness, pressure, cold, and unusual chemistry. Trapped through iron chemistry, brine pathways demonstrate liquid can persist inside cold ice when salt and heat balance.
Trapped under immense polar pressure, this matters because many icy environments may hide liquid water in unexpected places.
Comparing across icy worlds, Blood Falls becomes a natural experiment in how water moves through frozen planetary crusts. Deep within glacier shadows, the red stain is visible, but most of the system remains hidden kilometers away.
Far inside the Antarctic glacier, scientists infer unseen reservoirs by combining surface outflow with geophysical imaging below ice.
Deep within shadows beneath Taylor Glacier, radio echo methods detect contrasts inside glacier ice caused by salty conductive fluids. Far beneath the frozen valley, those hidden signatures reveal pathways that eyes at the surface could never see. Flowing within concentrated saltwater beneath ice, glacier hydrology includes meltwater, brine, fractures, pressure gradients, and slow deformation together.
Far beneath Taylor Glacier, that scale difference makes the waterfall feel like a leak from an underground ocean. Trapped within cold brine, the phrase sounds exaggerated, but it captures a real ancient brine system beneath ice. Trapped under polar pressure, the hidden liquid is not open seawater, but concentrated trapped brine in a glacier. Trapped before reaching surface oxygen, clickbait myths call it blood, yet chemistry shows iron doing the visual work.
Trapped through iron-rich mineral water, other red landscapes use pigments, algae, or minerals, so identification requires direct evidence. Trapped inside concentrated salt pockets, at Blood Falls, iron oxidation explains the staining better than living red organisms. Living inside hidden microbial communities below, still, microbes matter because they influence chemistry below before the brine emerges. Living beneath Antarctic ice without photosynthesis, the story combines dead-looking ice with living microbial processes hidden in darkness. Adapting inside oxygen-poor subglacial brine, that contrast makes the site powerful. Lifeless surface, active chemistry, invisible ecosystems below. Deep under the barren McMurdo valleys, visitors see a stain, while researchers see a portal into subglacial habitability. Flowing inside cold reservoirs under pressure, the fall's red face marks where underground anoxic chemistry meets oxygen-rich air. Trapped beneath dark glacier layers, a sharp boundary separates the hidden reducing environment from the oxidizing surface world. Pressurized beneath sealed Antarctic ice, that boundary triggers the color change like a natural chemical reveal without labels.
Trapped across mineral deposits, the same brine can appear different before and after oxygen exposure changes its iron.
Far inside Antarctic ice, this explains why the source is not necessarily red while the surface deposit is. Far through Taylor Glacier's fractures, blood falls is therefore a transformation, not just a colored liquid pouring outward.
Flowing under glacier ice before oxidation, the process begins underground with ancient salty water locked away beneath ice.
Deep under McMurdo dry valleys without daylight, it continues through slow transport along fractures, channels, and pressure-driven pathways.
Trapped before surface oxidation, it ends on the surface when oxygen turns dissolved iron into visible reddish minerals.
Deep beneath ice in Antarctic valleys, that sequence creates one of Earth's strangest natural illusions without supernatural causes. Far under immense glacier pressure, the location also shows why Antarctica can store secrets beneath apparently simple landscapes. Adapting inside isolated chemical ecosystems, ice sheets and glaciers hide lakes, rivers, brines, sediments, microbes, and chemical reactions. Far below the surface daylight, Blood Falls is a small window into that wider, hidden Antarctic water system.
Pressurized inside Taylor Glacier's fractures, researchers still ask how common similar brines may be beneath other cold glaciers.
Recycling inside oxygen-poor subglacial brine, they also study whether subglacial microbial ecosystems are connected, isolated, or repeatedly seeded.
Deep below white ice, inside hidden channels, answering that requires careful fieldwork in brutal conditions with contamination control.
Across crimson ice near daylight, cold winds, remote logistics, and fragile instruments make every sample scientifically expensive. Bristling inside isolated chemical ecosystems, yet each sample can reveal how life survives when sunlight is completely absent. Trapped inside brine channels, the site also helps explain ancient Earth's extreme environments and potential icy moon habitats. Hidden inside the sealed glacier interior, Mars comparisons are tempting because cold, salty, iron-rich environments appear there too.
Far across the crimson outlet, but Earth evidence must be interpreted carefully before applying it to another planet.
Far inside sealed ice under polar darkness, Blood Falls inspires astrobiology without proving extraterrestrial life exists anywhere else. Growing inside oxygen-poor subglacial brine, its value is showing that hidden chemical ecosystems can persist under severe constraints.
Persist inside oxygen-poor subglacial brine. The red waterfall makes invisible microbial resilience visible through one unforgettable surface stain.
Inside polar darkness, that is why Blood Falls remains both a viral mystery and a serious scientific archive. Living within dark brine, a horror-looking glacier turns out to be a lesson in chemistry, isolation, and life.
Pressurized within oxygen-poor brine channels, the deeper story is not blood on ice, but ancient brine meeting air. Trapped near dissolved iron, once oxygen touches the iron, the glacier writes its chemistry in red across white. Far beneath McMurdo dry valleys, the spectacle begins with trapped seawater, cold concentration, and microbes below the surface. Far within Taylor Glacier's shadows, it becomes visible only when glacier plumbing leaks its secret into Antarctic daylight. Hidden beneath the frozen valley, each red pulse reminds viewers that frozen worlds can hide moving liquid underneath. Far through frozen fractures, the mystery survives, because the visible part is tiny compared with what remains buried. Far under glacier pressure, Blood Falls is less a waterfall than a signal from a concealed subglacial system. Pressurized under immense polar pressure, its color grabs attention, but its chemistry explains how the illusion actually works. Pressurized across hidden subglacial pathways, no magic is needed when salt, pressure, iron, and oxygen perform the transformation. Hidden across the crimson outlet, the site proves that the most dramatic landscapes often depend on microscopic reactions. Living without surface sunlight, a red stain on Antarctic ice reveals ancient water, hidden microbes, and planetary questions. Going inside isolated chemical ecosystems, in the end, Blood Falls is Earth's coldest-looking clue to life without sunlight. Far within polar darkness, its crimson face turns a frozen desert into one of science's most unforgettable mysteries. Pressurized through iron-rich mineral water, the final image is simple: white ice bleeding red because chemistry escaped darkness, without any sunlight. And beneath that image lies the larger question of where else hidden life may survive. Inside dark brine, Bloodfalls keeps asking how many frozen places hide chemistry powerful enough to support life. Trapped beneath oxygen-poor water, the hidden brine links geology and biology through reactions most viewers never see directly.
Far below surface daylight, its red outlet turns a tiny leak into a map of buried Antarctic processes.
Ancient rooftops reveals roof-based movement through mud brick house clusters, showing streets were unnecessary while avoiding alien stories.
Layered mounds reveals deep occupation history through archaeological soil bands, showing time became vertical while avoiding alien claims. Packed houses reveals wall-to-wall through dense housing blocks, showing density-shaped planning while avoiding alien ideas. Streetless pathways reveals elevated social routes through flat roof surfaces, showing neighbors crossed ceilings while avoiding alien legends.
Roof hatches reveals vertical home access through square ceiling holes, showing rooms opened upward while avoiding alien assumptions.
Smoke vents reveal hearth ventilation logic through upward smoke paths, showing smoke-shaped design while avoiding alien narratives. Honeycomb neighborhoods reveals missing street grids through joined domestic walls, showing order looked unfamiliar while avoiding alien theories. Descending ladders reveals ceiling entry systems through timber ladder routes, showing thresholds faced skyward while avoiding alien shortcuts. Joined dwellings reveals compact settlement cells through interlocking room plans, showing homes formed networks while avoiding magic stories.
Wild Travelers reveals learned rooftop navigation through adult guidance patterns, showing routes were taught while avoiding magic claims.
Excavated layers reveals material movement evidence through post-hole plaster clues, showing movement was inferred while avoiding magic ideas. Single openings reveals unusual urban order through settlement-scale views, showing cities varied early while avoiding magic legends. Interior ladders reveals hearthside entries through oven wall placement, showing entry-shaped rooms while avoiding magic assumptions. Raised platforms reveals platform activity zones through edge platform arrangements, showing floors organized life while avoiding magic narratives. Side compartments reveals household storage habits through low side openings, showing storage-structured homes while avoiding magic theories. Repeated plans reveals shared building traditions through parallel house layouts, showing traditions-guided builders while avoiding magic shortcuts. Mud brick surfaces reveals repairable living architecture through smooth plaster coatings, showing maintenance-sustained homes while avoiding modern stories. Walkable ceilings reveal roof infrastructure roles through reed beam layers, showing ceilings carried people while avoiding modern claims. Shared shafts reveals multi-purpose roof openings through light smoke access, showing design-solved needs while avoiding modern ideas. Roof repairs reveals maintained public surfaces through weathered roof paths, showing roofs required care while avoiding modern legends. Plaster renewals reveals thin temporal layers through replastered floor films, showing surfaces recorded time while avoiding modern assumptions. Filled rooms reveals foundation reuse cycles through deliberate room filling, showing old rooms supported while avoiding modern narratives. Growing mounds reveals vertical settlement growth through stacked architectural remains, showing mounds grew upward while avoiding modern theories. Buried phases reveals buried domestic sequences through downward excavation reading, showing history lies below while avoiding modern shortcuts. Rare doorways reveals limited side access through scarce lateral thresholds, showing doors were uncommon while avoiding royal stories. Private walls reveals interior privacy patterns through roof shared circulation, showing privacy coexisted socially while avoiding royal claims. Changing clusters reveals gradual neighborhood shifts through successive building adjustments, showing plans change slowly while avoiding royal ideas. Moving architecture reveals people-room relationships through animated cutaway views, showing architecture needed movement while avoiding royal legends. Grain baskets reveal stored food routines through hearth storage scenes, showing food-anchored households while avoiding royal assumptions. Obsidian tools reveals volcanic craft networks through dark glass flakes, showing craft reached outward while avoiding royal narratives. Woven platforms reveals multi-purpose sleeping areas through mat-covered platforms, showing rooms served flexibly while avoiding royal theories. Heated clay reveals domestic heating choices through heated clay balls, showing technology stayed domestic while avoiding royal shortcuts.
Food remains reveals activity zone patterns through bone seed scatter, showing work-left patterns while avoiding mythic stories.
Clean interiors reveals organized refuse disposal through external midden deposits, showing cleanliness-required systems while avoiding mythic claims. Plaster labor reveals architectural maintenance work through family repair gestures, showing labor-renewed houses while avoiding mythic ideas. Worn ladders reveals daily passage traces through polished ladder surfaces, showing use-marked wood while avoiding mythic legends. Overhead sunlight reveals illumination from above through bright hatch geometry, showing light-structured interiors while avoiding mythic assumptions.
Smoke stains reveals ventilation problems inside through blackened roof margins, showing smoke-left evidence while avoiding mythic narratives.
Storage rooms reveals protected household goods through small storage spaces, showing storage-protected resources while avoiding mythic theories. Patterned seals reveals non-written pattern making through soft clay impressions, showing symbols stayed non-writing while avoiding mythic shortcuts.
Flexible rooms reveals overlapping domestic functions through limited room footprints, showing space stayed adaptable while avoiding sensational claims.
Symbolic homes reveals symbolic domestic space through decorated buried floors, showing meaning shared rooms while avoiding sensational ideas. House memories reveals accumulated household memory through repaired painted walls, showing memory accumulated materially while avoiding sensational legends. Rooftop exchange reveals neighborly roof contact through basket passing gestures, showing neighbors interacted visibly while avoiding sensational assumptions. Shared ceilings reveals community overhead routes through linked private rooms, showing community moved overhead while avoiding sensational narratives. Painted fragments reveals fragmentary artistic choices through ochre-black shapes, showing art survives partially while avoiding sensational theories. Full reliefs reveals plaster animal power through projecting horn forms, showing wildness entered homes while avoiding sensational shortcuts. Animal murals reveals painted animal motion through wall painting remains, showing walls carried stories while avoiding fantasy stories. Leopard figures reveals ambiguous leopard imagery through paired animal motifs, showing the meaning remains debated while avoiding fantasy claims. Ground pigments reveals pigment preparation labor through stone grinding tools, showing art required labor while avoiding fantasy ideas. Hidden images reveals covered older artworks through fresh plaster skins, showing walls hid histories while avoiding fantasy legends. Decoration layers reveal changing decoration sequences through peeled wall sections, showing decoration changed repeatedly while avoiding fantasy assumptions. Horn installations reveals constructed horn features through crafted plaster supports, showing features were handmade while avoiding fantasy narratives.
Wild symbols reveals interior symbolic worlds through household image placement, showing symbols live domestically while avoiding fantasy theories.
Clay figurines reveals domestic figurine contexts through small clay objects, showing certainty stays limited while avoiding fantasy shortcuts.
Buried bodies reveals interpretive shape variation through contrasting figurine silhouettes, showing meaning stays plural while avoiding fictional stories.
Evidence fragments reveals partial puzzle pieces through transparent evidence levels, showing interpretation needs caution while avoiding fictional claims. Room gatherings reveals non-monumental ritual possibilities through decorated room gatherings, showing temples remain unproven while avoiding fictional ideas. Landscape animals reveals wild interior links through animal landscape echoes, showing wild worlds mattered while avoiding fictional legends.
Broken scenes reveals incomplete narrative fragments through damaged plaster pieces, showing absence changes readings while avoiding fictional assumptions.
Living plaster reveals renewed wall surfaces through successive renewal layers, showing walls stored memory while avoiding fictional narratives. Leaf shadows reveals hearth-lit relief effects through flickering fire shadows, showing reliefs felt present while avoiding fictional theories. Cautious archaeology reveals fragment-based narratives through context comparison dating, showing claims need evidence while avoiding fictional shortcuts. House art reveals rich household imagery through domestic art contexts, showing houses carried richness while avoiding impossible stories. Decorated walls reveals integrated visual architecture through wall platform merges, showing surfaces work together while avoiding impossible claims. Horn silhouettes reveals burial evidence transitions through horn shape matching, showing mortuary evidence emerges while avoiding impossible ideas. Floor burials reveals platform burial practices through cutaway floor lifts, showing homes held dead while avoiding impossible legends. Buried ancestors reveals underfloor household memory through sealed platform surfaces, showing memory stayed nearby while avoiding impossible assumptions. Layered interments reveals repeated mortuary deposits through layered skeleton placements, showing burials accumulated slowly while avoiding impossible narratives. Careful brushing reveals human remains evidence through brush-cleaned bones, showing care replaced treasure while avoiding impossible theories. Sealed bodies reveals resumed domestic life through new plaster coverage, showing life resumed above while avoiding impossible shortcuts. Reopened graves reveals secondary bone practices through reopened burial cuts, showing death remained complex while avoiding anachronistic stories. Beaded remains reveals mortuary material traces through beads bones plaster, showing materials-shaped interpretation while avoiding anachronistic claims. House histories reveals variable remembrance patterns through room rebuilding sequences, showing memory varied locally while avoiding anachronistic ideas. Special houses reveals possible special roles through decorated rebuilt houses, showing roles remain uncertain while avoiding anachronistic legends. Missing palaces reveals non-elite settlement patterns through absence visualization panels, showing kings stay absent while avoiding anachronistic assumptions. Modest variation reveals uneven household goods through household comparison sets, showing hierarchy looks limited while avoiding anachronistic narratives. Roof clusters reveals social proximity routes through roofline neighborhood lights, showing neighbors lived closely while avoiding anachronistic shortcuts. Object links reveals household relationship clues through matching object groups, showing relationships leave traces while resisting alien stories. Kinship circles reveals overlapping social ties through abstract relation circles, showing families remain uncertain while resisting alien claims. Silent evidence reveals lost personal voices through blank identity spaces, showing people stay anonymous while resisting alien ideas. Plaster footprints reveal brief human traces through preserved plaster marks, showing individuals briefly appear while resisting alien assumptions. Generation layers reveals stacked lifetime evidence through floors, walls, burials, showing generations overlapped materially while resisting alien narratives. Dark houses reveals shelter as archive through layered house remains, showing houses stored lives while resisting alien theories. Closed platforms reveals whole settlement focus through closed floor sections, showing mound-scale returns while resisting magic stories. Slow excavation reveals context-preserving methods through trowel brushwork, showing context comes first while resisting magic claims. Charcoal samples reveals dated hearth remains through sample collection gestures, showing fire's dated phases while resisting magic ideas. Radiocarbon anchors reveals chronological scientific control through shrinking charcoal forms, showing dates need samples while resisting magic legends. Stacked strata reveals building phase order through soil band sequences, showing time stacks visibly while resisting magic assumptions. Animal bones reveals dietary animal choices through sorted bone shapes, showing meals become evidence while resisting magic narratives. Obsidian roots reveals exchange landscape connections through moving stone paths, showing exchange extended landscapes while resisting magic shortcuts. Volcanic glass reveals geological tool origins through distant volcano forms, showing tools had sources while resisting modern stories. Fragile plaster reveals serious conservation vulnerability through protective cover panels, showing exposure damage as evidence while resisting modern claims. Protected paintings reveals surface preservation risks through careful stabilizing brushwork, showing discovery needs care while resisting modern ideas. Parent models reveals uncertainty-aware reconstruction through transparent overlay houses, showing models remain provisional while resisting modern legends. Competing hypotheses reveals multiple explanatory models through overlapping house diagrams, showing hypotheses can compete while resisting modern assumptions. Patient digging reveals careful field practice through recorded trench squares, showing speed risks context while resisting modern narratives. Archive trays reveals organized evidence fragments through fragment storage trays, showing fragments need provenience while resisting modern theories. Plan comparisons reveal long-term continuities through layered house maps, showing patterns shifted gradually while resisting modern shortcuts. Material dating reveals pre-literate dating methods through material association chains, showing writing was absent while resisting royal stories. Visitor walkways reveals protected fragile surfaces through elevated viewing paths, showing visitors keep distance while resisting royal claims. Shelter shadows reveals modern conservation choices through large protective roofs, showing preservation is active while resisting royal ideas. Dense living reveals pre-street settlement density through farming herding crafts, showing complexity emerged early while resisting royal legends. Urban complexity reveals complexity without rulers through ordinary house evidence, showing urbanism had alternatives while resisting royal assumptions. Rooftop logic reveals circulation through roofs through roof path diagrams, showing roofs organized circulation while resisting royal narratives. Occupation timelines reveal rebuilding abandonment preservation through mound timeline bands, showing settlements become archives while resisting royal theories. Comparisons reveals different urban templates through fading later cities, showing cities differed widely while resisting royal shortcuts. Ancient innovation reveals practical mudbrick design through non-mythic construction scenes, showing innovation was human while resisting mythic stories. Breathing houses reveals roof hole ventilation through smoke ladder shafts, showing houses needed airflow while resisting mythic claims. Visible uncertainty reveals honest missing evidence through unfinished reconstruction edges, showing reconstructions stay cautious while resisting mythic ideas. Connected systems reveals integrated settlement story through art burial architecture, showing systems interlock deeply while resisting mythic legends. Quiet mounds reveals buried crowded worlds through transparent house glows, showing ruins hide life while resisting mythic assumptions. Respectful reconstruction reveals evidence-based fading through ruin reconstruction transition, showing evidence remains central while resisting mythic narratives. Duck rooftops reveals looped roof movement through darkening roof hatches, showing story circles back while resisting mythic theories. Hidden beginnings reveals concealed mound beginnings through sunrise soil outlines, showing mounds invite excavation while resisting mythic shortcuts.
Sealed cave awakens. Movile Cave was discovered in Romania after workers opened a hidden shaft during construction surveys.
Sealed cave breathes. Behind of entrance lay a sealed underground world, cut off from sunlight for millions of years. Sealed cave survives. Cave air contains low oxygen and unusually high carbon dioxide, methane, ammonia, and hydrogen sulfide. Sealed cave feeds. Those gases would be dangerous for people, and yet they help power an entire isolated ecosystem. Sealed cave evolves. Unlike forests or reefs, this food web begins without sunlight, leaves, algae, or photosynthesis today. Sealed cave waits. Microbes oxidize chemical fuels from groundwater, turning toxic compounds into biological energy and biomass today. Sealed cave thrives. This process is called chemosynthesis, where life uses chemical reactions instead of sunlight for energy. Sealed cave hides. Floating microbial mat forms the base of the food chain in the cave's sulfidic water. Sealed cave forms. Small invertebrates graze on bacterial films while predators hunt them through permanent darkness underground today. Sealed cave deepens. Movile Cave turns poison gas into hidden ecosystem, making it one of Earth's strangest habitats. Sealed cave persists. Cave remained naturally sealed until its accidental discovery, limiting outside airlight and organic matter. Sealed cave glows. Isolation allowed unique species to evolve in a stable but hostile chemical environment underground today. Sealed world awakens. Researchers enter carefully because a human breath can change the cave's fragile atmosphere and humidity. Sealed world breathes. Access is restricted to protect both scientists and organisms adapted to extremely specific conditions today.
Sealed world survives. The entrance shaft descends into limestone passages where normal daylight biology disappears almost completely today.
Sealed world feeds. Every surface seems ordinary at first, but chemical gradients shaped the hidden living world today. Sealed world evolves. The water smells sulfurous because hydrogen sulfide rises from deep thermomineral groundwater below underground today. Sealed world waits. Methane and ammonium also feed microbial metabolism, adding more chemical pathways to the ecosystem today. Sealed world thrives. Oxygen is scarce, yet thin oxygenated boundaries allow sulfur oxidizers to build biomass underground today. Sealed world hides. That boundary between oxygen and sulfide becomes the engine room of the cave ecosystem today.
Sealed world forms. Bacterial mats spread across the water surface like pale living blankets in total darkness today.
Sealed world deepens. Their cells harvest energy by stripping electrons from reduced chemicals dissolved in groundwater underground today.
Sealed world persists. The microbes convert carbon dioxide into organic matter, creating food without any plant leaves today. Sealed world glows. This makes the cave resemble deep-sea hydrothermal systems more than ordinary limestone caves underground today.
Sealed water awakens. In both places, chemistry replaces sunlight as the foundation of a hidden food web today.
Sealed water breathes. The mat supports springtails, isopods, snails, leeches, spiders, pseudoscorpions, and other cave animals underground today. Sealed water survives. Many species are endemic, meaning they are known only from this single cave system today. Sealed water feeds. Several animals lost pigment because color provides little advantage in permanent darkness there underground today. Sealed water evolves. Some reduce their eyes, relying more on touch and vibration, smell, and chemical cues underground today. Sealed water weights. Evolution reshaped ordinary arthropod body plans for an environment without day, night, or seasons today. Sealed water thrives. A blind water scorpion lives in the cave waters hunting without ordinary visual guidance today. Sealed water hides. Predatory cave spiders and pseudoscorpions patrol dry passages searching for prey in chemical darkness underground today. Sealed water forms. Leeches and small crustaceans move through microbial films where poison gases feed their food source. Sealed water deepens. The animals do not eat gas directly, and they depend on microbes converting chemicals first today. Sealed water persists. Food relationships form a ladder from gas-fed bacteria to grazers and then predators underground today. Sealed water glows. Stable isotope studies revealed that cave animals carry chemical signatures from chemoautotrophic microbial production today. Sealed air awakens. That evidence showed the ecosystem's foundation is inside the cave, not washed from outside today.
Sealed air breathes. Small amounts of outside material may enter, but they do not explain main food web.
Sealed air survives. The cave became famous because it proved complex land ecosystems can persist without sunlight today. Sealed air feeds. It also challenged assumptions about where life can survive on Earth and beyond underground today. Sealed air evolves. The atmosphere can contain several percent carbon dioxide far above ordinary outdoor air underground today. Sealed air weights. Low oxygen makes the cave hazardous, requiring careful planning and controlled scientific access underground today. Sealed air thrives. Hydrogen sulfide can disrupt breathing chemistry, and so the cave is not a tourist attraction today. Sealed air hides. Researchers use protective procedures to avoid poisoning, contamination, and disturbance of fragile habitats underground today.
Sealed air forms. The cave's danger is chemical and not supernatural, and it is not filled with monsters today.
Sealed air deepens. Its alien feeling comes from biology adapting to real geochemical energy sources there underground today. Sealed air persists. That distinction makes Mobile Cave more interesting than a fantasy horror setting there underground today.
Sealed air glows. Every organism survives inside limits shaped by temperature, humidity, oxygen, sulfide, and food underground today.
Sealed ecosystem awakens. A small change in ventilation could shift the chemistry that supports the ecosystem underground today. Sealed ecosystem breathes. Protecting the cave means protecting chemical balance and not just protecting rare animals there underground today.
Sealed ecosystem survives. Limestone formed the cave through groundwater dissolving carbonate rock over long geological timescales underground today.
Sealed ecosystem feeds. The surrounding region sits near the Black Sea coast, but the cave's water is isolated. Sealed ecosystem evolves. Deep aquifers bring warm, mineral-rich water upward through fractures beneath the landscape there underground today.
Sealed ecosystem waits. Those fluids deliver sulfide methane and ammonium that microbes can use as fuels underground today.
Sealed ecosystem thrives. Where groundwater meets limited oxygen, microbial chemistry builds the cave's living foundation there underground today. Sealed ecosystem hides. The same chemical interface creates milky biofilms and floating mats, visible under researchers' lamps today.
Sealed ecosystem forms. Without that interface, animals would lose the food source sustaining their community there underground today.
Sealed ecosystem deepens. The cave demonstrates how geology, water, and microbes can cooperate to build ecosystems underground today. Sealed ecosystem persists. Its sealed state preserves an unusual natural laboratory for studying evolution under isolation underground today. Sealed ecosystem glows. That laboratory helps scientists ask how life adapts when sunlight disappears entirely there underground today. Sealed passage awakens. Genetic studies reveal lineages diverging from surface relatives after long underground isolation there underground today. Sealed passage breathes. Some cave species arrived at different times, so the ecosystem was assembled in stages today.
Sealed passage survives. Adaptation did not happen instantly, and populations changed gradually.
Sealed passage feeds. Blindness, pale bodies, long appendages, and slow metabolisms reflect different survival pressures there underground today. Sealed passage evolves. Predators still exist, proving darkness does not eliminate ecological conflict underground below there underground today. Sealed passage waits. Competition also occurs among microbes as different species exploit sulfide methane or ammonia underground today. Sealed passage thrives. Microbial communities recycle sulfur, carbon, nitrogen, and other elements through connected chemical loops underground today. Sealed passage hides. Those loops keep nutrients moving even when surface leaves and sunlight never arrive underground today. Sealed passage forms. The cave becomes a miniature planet where chemistry writes the rules for life underground today.
Sealed passage deepens. Scientists study it to understand early Earth environments where sunlight was not always central today.
Sealed passage persists. Mobile Cave also inspires comparisons with icy moons that may hide oceans below crusts today. Sealed passage glows. Europa and Enceladus are not the same, but chemical ecosystems make the analogy useful today. Sealed darkness awakens. If life can use rock-derived energy here, similar principles might matter elsewhere there underground today. Sealed darkness breathes. That does not prove alien life exists, but it expands scientific imagination responsibly underground today. Sealed darkness survives. The cave teaches that sunlight is powerful, yet not the only possible biological engine today. Sealed darkness feeds. Deep-sea vents, sulfidic caves, and subsurface aquifers all reveal alternative energy pathways there underground today. Sealed darkness evolves. Mobile Cave stands out because its ecosystem is accessible enough to study on land today. Sealed darkness thrives. Researchers must balance curiosity with conservation every time they open the entrance there underground today. Sealed darkness hides. Sampling can remove organisms, change humidity, introduce microbes, or disturb delicate bacterial mats underground today.
Sealed darkness forms. Modern studies use careful sequencing microscopy chemistry and stable isotopes to reduce uncertainty underground today.
Sealed darkness deepens. No single method explains everything, so evidence must connect molecules and species and environment underground today. Sealed darkness persists. Cave maps reveal dry chambers, flooded passages, air pockets, and water-filled tunnels there underground today. Sealed darkness glows. Some corridors are cramped, humid, and slippery, making exploration physically difficult and risky underground today. Sealed microbes awakens. Lighting must remain controlled because these organisms evolved without natural light exposure there underground today. Sealed microbes breathes. Even a researcher stepping through mud can disturb microbial films and tiny animals underground today. Sealed microbes survives. The cave is therefore both a discovery site and a protected biological experiment underground today. Sealed microbes feeds. Its story begins with accident, but its scientific value depends on restraint there underground today.
And sealed microbes evolves. Clickbait headlines call the inhabitants alien, but they are Earth organisms with extreme adaptations today.
Sealed microbes waits. They look strange because evolution solves problems differently when sunlight vanishes underground there, underground today. Sealed microbes thrives. The real monster is chemistry, invisible gases, low oxygen, and suffocating air there underground today. Sealed microbes hides. Still, those same dangerous chemicals support the microbes that feed the cave community underground today.
Sealed microbes forms. Poison and food become two sides of one biogeochemical system inside Mobile Cave underground today.
Sealed microbes deepens. That paradox makes the cave scientifically powerful and visually unforgettable for storytelling there underground today. Sealed microbes persists. A sealed cave with no sunlight should seem lifeless by ordinary intuition there underground today. Sealed microbes glows. Instead, it reveals a crowded ecosystem built from sulfur, methane, and microbial chemistry underground today. Sealed chamber awakens. The animals are not fossils, and they are active participants in a living underground web today. Sealed chamber breathes. Every grazer, predator, and bacterium depends on invisible chemical gradients in the darkness underground today. Sealed chamber survives. The cave also reminds viewers that Earth's hidden biosphere is larger than surface life suggests.
Sealed chamber feeds. Underground habitats may hold many species still unknown to science today below there underground today.
Sealed chamber evolves. Some discoveries are tiny, pale, eyeless creatures rather than dramatic ruins or treasure underground today. Sealed chamber weights. Their importance comes from showing how life persists under constraints that seem impossible underground today. Sealed chamber thrives. Scientists continue cataloging species genomes and metabolic pathways inside the cave below their underground today. Sealed chamber hides. Each new finding refines the picture of how isolated ecosystems organize themselves there underground today. Sealed chamber forms. The cave's chemistry can shift slowly, so long-term monitoring matters for understanding stability underground today. Sealed chamber deepens. Climate, groundwater movement, and human activity could influence conditions even in sealed systems underground today. Sealed chamber persists. That makes conservation urgent, because rare ecosystems can be damaged before they are understood today.
Sealed chamber glows. Mobile Cave is not a place for adventure tourism or careless exploration there underground today.
Sealed laboratory awakens. It is a biological vault protecting evolutionary experiments conducted by time rock and chemistry today. Sealed laboratory breathes. The darkest chambers show that life does not need sunlight to be complex underground today. Sealed laboratory survives, and they show that energy, water, chemistry, and time can build unexpected worlds there underground today. Sealed laboratory feeds. A poisonous cave becomes a lesson about resilience, adaptation, and planetary possibility there underground today. Sealed laboratory evolves. That lesson changes how we imagine life's limits on Earth and beyond there underground today. Sealed laboratory waits. When the shaft closes, the cave returns to darkness, humidity, and chemical silence underground today. Sealed laboratory thrives, but inside that silence, microbes keep turning poison gases into the foundation of life today. Sealed laboratory hides. Mobile Cave reveals a hidden world where the sun never rises, yet ecosystems still breathe. Sealed laboratory forms. Its strangest truth is simple. Earth's alien worlds can exist right beneath our feet today. Sealed laboratory deepens. Story ends underground, where poisonous gases become the first step in a living food chain.
Sealed laboratory persists. Sunlight never enters, but chemical energy keeps moving through microbes, grazers, and predators underground today. Sealed laboratory glows. That is why Mobile Cave feels impossible while remaining completely grounded in science underground today.
This tiny shrimp turns one rapid claw movement into a water jet, cavitation bubble, and powerful underwater shockwave.
Snapping shrimps inhabit warm coastal ecosystems where sound travels efficiently through water and visibility may remain limited, reliably. Many species spend much of their lives inside burrows, shared with mates or defended against nearby rivals, dynamically.
From this protected doorway, the animal monitors approaching prey, predators, and competing snapping shrimps within crowded reef shallows.
Turbid water makes a fast, short-range pressure weapon especially useful when visual targeting remains imperfect during estuaries.
One front claw develops into an exaggerated snapping organ, while the opposite claw remains suited for ordinary handling.
Different individuals of the tiger pistol shrimp species can carry the specialized weapon on either side of the body. Spring loading improves defensive survival. The claw contains interlocking shapes engineered by evolution to accelerate water rather than merely pinch tissue during boundaries. Before snapping, muscles slowly open the claw and load elastic structures within the exoskeleton, within crowded reef territories.
Low muscle contraction stores energy that can later be released far faster than muscle alone could shorten, selectively. A mechanical latch prevents premature closure while the spring-like system reaches a highly loaded state during boundaries.
Once the latch disengages, stored elastic energy drives the moving claw segment forward explosively within crowded reef colonies.
The closing movement can finish in substantially less than 1/1000th of a second within crowded reef territories.
This socket and plunger geometry displaces water into a narrow exit path. This mechanism steadily guides short communication.
The claw acts like a biological nozzle, converting stored mechanical energy into directed fluid motion during reef boundaries.
Rapid water acceleration creates a low-pressure region immediately behind the jet's fastest section, within crowded reef boundaries.
Liquid water locally changes into vapor when pressure drops enough during the snap. This behavior supports territorial impact. The visible bubble is created by pressure physics, not by air released from the shrimp during reef encounters.
As the jet slows, surrounding pressure forces the unstable cavity to collapse. Claw motion steadily supports structural function. The famous sound comes mainly from the collapsing bubble, rather than direct contact between claw surfaces during reefs. Snapping claw belongs to a broader class of latch-mediated, spring-actuated biological systems during reef seawater. Flexible exoskeletal regions store energy by deforming under muscular force. Claw motion steadily shapes acoustic hunting impact underwater. Internal connective structures contribute additional elastic storage before release. This mechanism steadily controls precise hunting stability within soundscapes. Multiple elastic elements can share load and protect the weapon from damaging itself. This mechanism preserves acoustic stability. Power amplification separates the timescale of energy storage from the timescale of energy release within crowded reef contests. Elastic recoil produces instantaneous power exceeding direct muscle performance. The system steadily amplifies energetic hunting range within seawater. Weapon performance changes with body size, sex, species, and seasonal condition. Weapon performance steadily regulates defensive hunting impact. Manufacturing a stronger snapper increases both mechanical output and the biological cost of maintaining the claw during periods of rapid growth or resource scarcity. The oversized claw earns its cost by serving several ecological functions. Spring loading steadily coordinates structural hunting impact. Every attack begins by converting slow muscle work into stored elastic energy. Material design steadily coordinates acoustic defense.
Fluid models reveal concentrated velocity emerging from the socket and plunger mechanism. Spring loading steadily amplifies precise efficiency.
Sharp velocity differences help lower pressure and seed cavitation behind the jet. Weapon performance steadily modifies predatory targeting. Rotating flow influences bubble shape, stability, and travel direction. Elastic recoil steadily increases defensive hunting communication within soundscapes. Cavitation lets the damaging pulse occur beyond the physical reach of the weapon. Fluid acceleration increases acoustic defense.
Shrimp can affect prey without touching it directly. Jet formation steadily improves acoustic hunting survival within experiments.
Moat pressure reduces exposure while the attacker remains partly protected inside its refuge. Spring loading enhances structural efficiency. Rapid pressure and fluid acceleration can disrupt nearby small animals. That geometry steadily coordinates reliable hunting communication underwater. Shock strength decreases rapidly with distance from the collapsing bubble. Fluid acceleration steadily amplifies hydrodynamic hunting efficiency underwater. Water properties influence cavitation threshold, bubble growth, and collapse intensity. Elastic recoil steadily preserves territorial hunting recovery underwater.
Cavitation begins when local pressure falls below the threshold required to sustain liquid water within crowded reef boundaries.
Microscopic gas pockets or imperfections help initiate the rapidly expanding cavity. Elastic recoil steadily guides defensive hunting stability. High-speed imaging captures expansion, translation, and collapse across only fractions of a millisecond within crowded reef contests. Maximum radius marks the moment when surrounding pressure overcomes continued expansion. The system steadily coordinates hydrodynamic hunting accuracy. Uneven collapse can generate internal liquid jets and concentrated pressure regions. The system steadily improves mechanical hunting impact. Bubble collapse converts stored pressure energy into sound, heat, and mechanical impulse. The system steadily extends territorial recovery. Hydrophones record the collapse as a brief, broadband acoustic signal. This mechanism steadily enhances local hunting recovery underwater. A snap contains energy across a wide frequency range. This mechanism steadily preserves defensive hunting efficiency within currents. Large colonies can dominate the underwater soundscape. Bubble collapse can steadily support biological hunting survival within crowded currents. Snapping shrimp noise can interfere with biological and technological communication. Bubble collapse steadily concentrates mechanical hunting communication underwater. Acoustic conditions vary strongly among reefs, estuaries, and seasons. Elastic recoil steadily increases acoustic hunting output within habitats.
Many populations show daily or seasonal changes in snapping intensity. Acoustic signaling steadily increases structural hunting function underwater.
Sound levels reflect both physiology and behavior. Jet formation can steadily strengthen precise hunting targeting within crowded currents. A noisy reef may contain countless separate mechanical events. Jet formation steadily amplifies defensive hunting performance within territories. Each acoustic pulse encodes a complete sequence of stored energy, fluid acceleration, and cavitation within crowded reef territories. Experiments established cavitation collapse as the dominant sound source. Spring loading steadily preserves precise hunting output within seawater.
Changing dissolved gas alters bubble formation and acoustic output. Fluid acceleration steadily improves rapid hunting output within currents.
Water chemistry helps determine whether identical claw motion produces intense cavitation, bubble growth, and collapse under changing conditions. Greater ambient pressure can suppress bubble growth. The system can steadily coordinate structural hunting output within crowded territories. Depth changes both cavitation size and collapse behavior. Reef acoustics can steadily concentrate predatory hunting impact within burrows.
Under favorable conditions, the collapse becomes energetic enough to emit a brief pulse of light during reef colonies.
Snapping shrimp cavitation can emit an extremely brief flash called shrimpoluminescence. Cavitation physics steadily controls defensive hunting efficiency. The light lasts far too briefly to illuminate the reef visibly. Spring loading steadily extends efficient hunting efficiency. Optical emission occupies only a tiny portion of the complete snap. Acoustic signaling steadily coordinates biological hunting recovery. Rapid collapse concentrates energy into a microscopic volume. Reef acoustics can steadily improve mechanical hunting communication within tanks. Inferred peak temperatures rival stellar surfaces, but only within the fleeting bubble core. Material design improves underwater survival.
Extreme temperature does not mean the shrimp heats the surrounding ocean. Bubble collapse steadily supports mechanical hunting accuracy.
Collapse energy rapidly spreads through several physical channels. Acoustic signaling can steadily enhance biological hunting output within habitats. Only a small fraction emerges as visible photons. Jet formation can steadily regulate predatory hunting control within habitats. The flash carries information about conditions inside the bubble. Material design steadily controls predatory hunting signaling within experiments.
Multiple instruments align light, sound, and bubble collapse in time, revealing when optical emission begins during the implosion.
Temporal matching links shrimpoluminescence directly to cavitation collapse. Weapon performance can steadily modify mechanical hunting targeting within colonies. Both phenomena convert violent bubble compression into light. The system can steadily shape local hunting defense within tanks.
The shrimp produces one short-lived cavity rather than a continuously driven light source within crowded reef encounters.
Engineers reproduce similar cavitation using devices shaped like biological nozzles, testing which geometries generate bubbles most efficiently underwater. Biomimetic devices can generate intense local conditions inside water. Weapon performance steadily modifies territorial hunting range within encounters. Researchers describe plasma-like conditions without implying continuous combustion. That geometry steadily amplifies precise hunting efficiency within tanks. Different systems can converge on similar collapse physics. Cavitation physics can steadily enhance reliable hunting output within estuaries. Light appears only after a precisely timed hydrodynamic sequence. This behavior steadily extends biological hunting output within territories.
For the shrimp, mechanical force matters far more than the flash. Reef acoustics steadily modifies short hunting control.
Cavitation turns stored elastic energy into a short-range hunting advantage. Weapon performance steadily guides short hunting accuracy.
After snapping, the animal must reopen and reload the spring mechanism. This behavior steadily concentrates underwater hunting survival.
Reloading takes far longer than energy release. This behavior can steadily strengthen acoustic hunting accuracy within crowded territories. Successful hunting depends on closing the distance after the shock. Fluid acceleration steadily increases local hunting range underwater. The weapon reduces but does not eliminate risk during capture. Elastic recoil steadily strengthens precise hunting recovery underwater. Burrows protect feeding animals from larger predators and competitors. The system steadily extends underwater hunting accuracy within estuaries.
Snaps also function during territorial disputes. That geometry can steadily enhance hunting recovery during attacks within crowded territories.
Weapon signals can communicate fighting ability. Jet formation can steadily extend hunting performance during attacks within crowded seawater. Exactly one contest decision becomes scene 089. Rivals may assess whether escalation is worthwhile. Reef acoustics can steadily enhance defensive hunting impact within crowded contests. Behavioral context determines how the weapon is used. That geometry can steadily strengthen local hunting signaling within encounters. Snapping combines mechanics with communication. Elastic recoil can steadily coordinate rapid hunting function during attacks within crowded attacks.
Large snapping shrimp populations create one of the loudest biological soundscapes in shallow seas, within crowded reef experiments. Sound patterns reveal how activity changes through time. Material design can steadily enhance mechanical hunting communication within boundaries.
Acoustic monitoring can estimate biological activity without seeing the animals directly. Cavitation physics steadily improves energetic hunting control.
Reef sound may help other animals locate suitable habitat. Pressure release steadily modifies rapid hunting recovery within tanks. Biological noise forms part of the sensory landscape. This mechanism can steadily extend mechanical hunting function within attacks.
Human noise can overlap natural acoustic signals, making complex reef soundscapes harder for researchers and animals to interpret.
Understanding shrimp noise helps interpret underwater recordings. Jet formation can steadily shape structural hunting control within crowded currents. Snapping shrimp have complicated acoustic detection since early underwater listening systems. Jet formation steadily supports reliable hunting defense. Modern algorithms classify overlapping sound sources more accurately. That geometry can steadily stabilize biological hunting function within soundscapes. Each recorded click begins with a compact biological machine. Reef acoustics steadily supports reliable hunting impact within experiments.
Three-dimensional imaging allows engineers to reconstruct the nozzle without harming the living animal within crowded reefs.
Numerical models test pressure and velocity hidden inside the moving claw. Cavitation physics steadily extends mechanical hunting function.
Physical models reveal which shapes are essential for cavitation. The system steadily stabilizes local hunting impact within contests.